be reporting about directional control valves, presented by Arajin Choco, Mariel Meralit, Giro Subiato, Wilbert Samilang, Engelbert Monterrey, Jonathan Cabarubias, and Mr. Marvin Mutia. Let us talk about its configuration and construction. But first, let us define this device. So directional control valves are devices which influence the path taken by an airstream. So it normally involves one or all of the following: opening the passage of air and directing it to particular airlines, canceling air signals as required by blocking their passage, relieving the air to atmosphere via an exhaust port. So it is also characterized by number of controlled connections or ways, number of switching positions, and method of actuation. So the normal position on valves with existing reset, for example, is in a spring, refers to the switching position as shown by the moving parts of the valve if the valve is not connected. So the initial position is the switching position as shown by the moving parts of a valve after the valve has been installed in a system and the system pressure has been switched on and possibly also the electrical voltage, and with which the designated switching program starts. So as per the constructional principle of a directional control valve, it is an important factor as far as service life, switching time, time of actuation, connection methods, and size is concerned. So as per the designs, there are two kinds or categories of this, one of which is the poppet valves. So there are two kinds of poppet valves. There is a ball seat valve and a disc seat valve. So the connections are opened and closed by means of balls, discs, plates, or cones. The valve seats are usually sealed, simply used flexible seals. Seat valves have few parts which are subject to wear, and hence they have a long service life. They are insensitive to dirt and are robust. So the actuating force is relatively high, as it is necessary to overcome the force of the built-in reset spring and the air pressure.
Poppet valves have a slender stem and mushroom-shaped head. When utilized in a piston engine, they work by opening and closing the intake and exhaust ports in the cylinder head. The engine maneuvers the valves by pushing on the stems with cams and cam followers. So as you can see in the picture, there is an exploded view of the poppet valves.
So the next slide, we will be showing a video on how a poppet valve works. The second design is called slide valves. So there are three kinds of slide valves, namely longitudinal slide valve, or also known as spool valve, longitudinal flat slide valve, and plate slide valve. So in slide valves, the individual connections are linked together or closed by means of spools, flat slide or plate slide valve.
It is a movable element in a system for controlling a thermal or mechanical process. Directs the flow of a working fluid or gas into the proper channel by displacement relative to ports in the surface over which it slides. So as you could see in the picture, there is a picture of a slide valve. So in the next slide, we'll be showing you how slide valves work or the mechanism of it.
All G-Force one-piece nozzles contain the legendary TFT stainless slide-style shutoff valve. Whether you choose fixed, selectable, or automatic models, the slide valve provides turbulence-free stream performance even when the nozzle is gated and flow is restricted. Unlike competitive ball-style shutoff valves, the slide-style valve introduces no turbulence into the stream when gated, maintaining a high-velocity, hard-hitting straight stream and a wide protective fog pattern.
The two-way valve has two ports of two positions, open and closed. It is rarely used except as an off valve, since its only function is to enable signal flow through and cannot release the air to atmosphere once in the closed position, in contrast to the two-way valve. The two-way valve is normally of the ball seat construction. This valve can be operated either manually, mechanically, or pneumatically. When fluid enters the inlet part A of a two-way valve, the relative position of the plug dictates the amount of fluid allowed to leave the outlet port AB. When the plug and spindle are positioned all the way up, the valve is fully from ports A to AB. Thank you.
2 by 2 sliding spool type direction control valve. In normal position, there is no connection from A to B. Fluid cannot flow from A to B. The symbolic representation is shown here. A is closed, B is closed. There is no connection from A to B, and hence fluid cannot flow from A to B in normal position. When the palm button is pressed, connection is made from A to B. Fluid can flow from A to B. This is the symbolic representation. There is an arrow from A to B. It says there is connection from A to B. Fluid can flow from A to B.
So the two-way valve. The two-way valve is a signal generating valve with the characteristic that a signal on the output side of the valve can be generated and also cancelled. The two-way valve has 3 ports and 2 positions. The addition of the exhaust port 3 enables the signal generated by the passage through two-way valve to be cancelled. The valve connects the output signal 2 to exhaust 3 and thus to atmosphere in the initial position. A spring forces a ball against the valve seat, preventing the compressed air from flowing from the air connection 1 to the working line 2.
4.3 Two-way valve. The cylinder moves in one direction by filling the air chamber and returns by spring force. The two-way valve either fills the air chamber or vents the chamber to the atmosphere. Two-way valve, normally closed ball seat. Actuation of the valve plunger causes the ball to be forced away from the seat. In doing this, the opposing force of the reset spring and that generated from the compressed air must be overcome. In the actuated state, connection 1 and 2 are connected to the valve is switch flow. The valve is actuated either manually or mechanically. The actuation force required is dependent on the supply pressure, spring force, and the friction in the valve. The actuation force limits the feasible size of the valve. The construction of the ball seat valve is very simple and compact. So this is the photos and the circuit diagram. In this circuit, the two-way valve 1S controls a single acting cylinder 1A. The push-button activated valve is at rest with the 1-port block and the cylinder exhausted to atmosphere via 2 to 3. The operation of the push-button diverts the one supplied to the 2-port and the cylinder extends against spring force. When the push button is released, the valve returns by spring and the cylinder is returned to its initial position by the cylinder return spring. Circuit diagram controlling a single acting cylinder. Two-way valve. Disc seat normally closed and actuated. The valve shown here is constructed on the disc seat principle. The sealing is simple but effective. The response time is short and a small movement results in a large cross-sectional area being available for airflow. Like the ball seat valves, they are insensitive to dirt and thus have a long served life. The two-way valves are used for controls employing single acting cylinders or for generating signals supplied to control elements. This is the picture and the diagram. Two-way valve. Disc seat normally closed, actuated. A two-way valve in which the normal position is open to flow from 1 to 2 is referred to as normally open valve. Initially, the 1-port is connected to the 2-port through the stem of the valve and the valve disc seat is closed at the 3-port. When the plunger is operated, the 1 air is initially blocked by the stem seat and then the disc is pushed off its seat to exhaust the output air to atmosphere via the passage 2 to 3. When the plunger is released, the piston with the 2 sealing seats is returned to the initial position by the return spring. Once again, the 3-port is blocked and air is supplied from 1 to 2. So this is the 3 two-way valve disc seat normally open unactuated, and 3 two-way valve disc seat normally open actuated. In circuit diagram, controlling a single acting cylinder. In this circuit diagram, pressure is applied to the single acting cylinder via the 3 two-way valve in normally open position 1V. The cylinder piston has advanced into the initial position if the valve is actuated. The air supply from 1 to 2 is shut off. The piston chamber is exhausted by port 2 to 3 and the piston rod retracts due to the force of the return spring.
In three two-way hand slide valve, the construction is simple. Actuation is affected by displacing the grip sleeve lengthwise. This valve is used as a shut-off valve, primarily for the pressure and exhausting control of control system or system components. The following depicts the symbol and actual view of a three two-way hand slide valve. This video show the working principle of a three two-way hand slide valve.
This is our 3-position 2-port hand slide valve. You would use this valve as a means of applying air to tools. So in this demonstration I've just got a silencer at the end. Your air supply goes into the female port. So we're applying air and to switch the air on, you just slide valve over like so.
For this video, controlling a single acting cylinder will be simulated.
Okay. Single acting cylinder looks like this, where it has the one port. When we put that air to that one port, it's going to push against the spring and extend the cylinder. Once we release that air from the cylinder, then the spring retracts it to the initial position. Okay, so this would be your rest position for the single acting cylinder. Okay, looks like this, right? Single port. Once you put air to here, then it's going to extend the cylinder. Excellent. Okay, we're also talking about direct control. We're going to get into indirect control later on, but direct control is just by pushing the push button, then we're going to have direct control over the actuator. Indirect control would be pushing the push button, controls a relay, that relay controls the actuator. So direct control is by pushing the push button, you have direct control over the output. Okay, that's our circuit right there, but let's build it up slowly. Okay, so pneumatic slab number 1, we need to start with a box, or more a rectangle. Okay, what we're going to do is we're going to separate this into 2 positions of this switch. And for these guys, it said that there was going to be a push button control. So we're going to put a push button on the end here. Okay, on the other side, we're going to put a spring, because the push buttons that we're using are spring actuated, in that when you let go of the push button, then it's going to return to its rest state. Okay, next thing we need is our ports. So there are there are 3 ports to these guys, and in the rest position, it said that this guy was a normally closed valve. So I'm going to block 1, and then we've got 2 other ports that we're going to make use of. Okay, that's one position of the switch. Now I need to supply that switch with some air. So there are sexier ways to do this, but I'm just going to use a triangle here to denote my compressed air source. Okay, that guy's going up to my first port. So I'm going to label that port number 1. That's my supply. Okay, going from there, I'm going to go to my single acting cylinder. So I'm just going to draw in a single acting cylinder. And a single acting cylinder needs a way for it to retract. So there's a spring in there to retract that cylinder. Excellent. Now I need to have a tube going from my push button to that single acting cylinder. That's the output. So the output is going to be labeled number 2. Okay, hydraulics is a closed system. Pneumatics is an open system, meaning that once the circuit is finished doing its work, then the compressed air is exhausted out to atmosphere. So we need to incorporate an exhaust here. So we'll throw in an exhaust port, and that guy is labeled number 3. Okay, on the other side, or the other position of this valve, then we have the exact same port. So I've got port 1, port 2, and port 3, similar to these guys that we have 1, 2, and 3. Exact same ports, but they're going to be performing a different function. In the other position of the switch, we're going to have air going from 1 up to 2. And at that point, we're going to block off our exhaust. And that's it. That's our diagram for the first lab. Okay, all we need to do is just kind of throw in the rest of the information to make everything clear now. So port 1 went to our supply. Port 2 went to the actuator. Easy note, what's going on there? And port 3 is the exhaust. Okay, the only thing we have to hook up though is port number 1 and port number 2. Port number 3 is integral to the actual switch. So you don't have to hook anything up to the exhaust. It just is an integral portion of that switch, nothing to hook up whatsoever. What else do we have that we can take off this diagram? Well, this guy right here, this spring, that's going to tell us the rest state. Okay, meaning that when that spring causes that push button to go back to its rest position, then this portion of our rectangle will be the rest position for that switch. This portion that corresponds to the push button, that's going to be our activated portion of the switch. Okay, this switch that we're using is called a 3-2 on manually operated but push button actuated valve. Okay, what does the 3 and the 2 denote? The 3 denotes the number of ports. The 2 denotes the number of positions of the switch. Okay, we said that this guy was normally closed, so it's a little bit backwards, in that everything electrically is kind of backwards from PLCs or from pneumatics. So normally we would think of a normally closed contact like this, meaning that current could go through to our load. In this case, when they say normally closed, it's acting more like a normally open contact, electrically speaking, meaning that it is normally closed to the passage of air. So you'll find the same thing when we get into PLCs. Everything's a little backwards from the way that we normally look at contacts. So this guy is a normally closed pneumatic contact in that it is normally closed to the passage of air, and you can see that the air source is blocked by that T connection there. Okay, any air that was trapped inside of that cylinder, once it extends, the spring is going to push it back, and then we've provided a way for that air to exhaust out of 3. Okay, that's everything we need for this diagram. I'm going to pause it here, and I'll bring up the Festo fluid sim, and we'll be able to simulate this.
In pneumatically actuated 3-way valve, it is operated by an air signal up 12. The circuit diagram shown illustrates a pneumatically actuated valve with spring return in normally closed position. In an 3-way valve single pilot normally closed with spring return unactuated, air applied at the 12 port, then it moves the valve plunger against the reset spring. The connections 1 and 2 are connected upon release of the signal at port 12. The pilot spool is returned to the initial position by the return spring. The disc closes the connection between 1 and 2. The excess air in the working line 2 is exhausted through 3. The single pilot 3-way valve with return spring can be configured as normally closed or normally open. The pneumatically actuated valve can be used as a control element when used in an indirect control. The signal for extension of the cylinder 1A is initiated indirectly by a push-button 3-way valve, as 1S is which supplies the control signal to the control element 1B. For the normally closed position, ports 1 and 3 only need to be inversely connected to the normally closed position. The head of the bulb with port 12 can be rotated in 180 degrees. The designation of the pilot port is then 10. If a normally open bulb is used at the position of bulb 1B, then the cylinder is initially extended and upon operation of the push button of bulb 1S, then the cylinder retracts. Servo-controlled 3-way roller lever bulb. Piloted bulbs require only minimal actuating forces. A small hole connects the pressure connection 1 and the pilot bulb. If the roller lever is operated, the pilot bulb opens. Compressed air flows to the diaphragm and actuates the main bulb disc. Compressed air flows to the diaphragm and actuates the main bulb disc. The first effect is the closing of path 2 to 3, followed by the second disc seat opening to airway from 1 to 2. The return position is affected by means of releasing the roller lever, thereby closing the pilot bulb. The bulb is exhausted by the hollow stem. The pilot piston of the main bulb is returned to its initial position by the reset spring. For figure 4.14, pilot bulb is left unactuated and the right is actuated. This type of bulb can be used as either a normally closed bulb or normally open bulb by changing ports 1 and 3 by rotating the head into 180 degrees. As you can see, there are two 3-way roller level bulbs of an internal pilot. The one is normally closed, the second one is normally open. For this video, it will simulate the two kinds of 3-way roller level bulb.
This is a 3-2 roller valve. It has a valve body, a roller lever, and an internal moving part. This is the cross-sectional view of the 3-2-way roller valve, without the roller lever. Only the moving part, and valve body are shown. Let's now see the animated view of the valve in action. The detailed explanation of each valve position will follow. When the roller valve is not activated, compressed air supply to port 1 is blocked. But port 2 and 3 are connected. That is, air can travel freely between the two ports. Note that port 3 is normally an exhaust port, air escape to atmosphere through this port. Try to trace out the air path of the cross-sectional view and the symbol shown. They both correspond to each other. When the roller valve is activated or switch over to another position, compressed air supply to port 1 is connected to port 2. Compressed air coming out of port 2 can be connected to the input port of the next pneumatic device and activate that device. Note that at this switching position, port 3 is blocked. At this switching position, the valve symbol has an additional part added, to indicate the valve is activated when constructing a pneumatic circuit diagram.
In roller level bulb with idle return, the roller lever bulb with idle return only switches if the movement of the trip cam on the roller lever is in a certain direction. The valve is used as a limit switch for the position sensing of the extended and retracted piston rod. Care should be taken to ensure that the bulb is fated in the correct direction of the movement. Likewise, this type of bulb can be used either in normally open or normally closed position. In this case, the normally open position only ports 1 and 3 are needed to be inversely connected to the normally closed position. The head of the bulb with roller lever actuator can be repositioned by 180 degrees. Here's the actual and symbol of a roller lever bulb with idle return.
Okay, good morning sir, good morning classmates. Ang re-report ko o di-discuss ko sa inyo is tungkol sa 4-way valves. Pag sinabing 4-way valves has 4 ports and 2 position. Tapos pag sinabing this seat is for two-way valves is similar to constructed of three two-way valves. One normally is open and the other is normally closed. Gito ang itsura ng for two-way valves, this seat of actuated. Ito. Gito ang itsura niya. Yan. Pag sinabi namang for two-way valves, this seat of ang actuated is actually of the valves when the two plunger are actuated simultaneously 1:2 and 4:3 are closed the first movement. By press the value plunger pounder against the disc, opposing the reset spring force to passage between 1 and 4 from 2 and 3 open. Pag sinabing yung 1:2 ito 1:2 tapos 3 and 4. Pag plunger naman, plunger yung decit is 1:4 tapos 2:3. Parang kabaligtaran lang siya pag may decit. The value has a no overlapping exhaust connection and the return to its start position by the spring. The valves are used for control employing double acting cylinder. There are other actuating methods and types of constructed available for the four two-way valves, including the push button, single air pilots, double air pilots, roller lever actuated, spool, and sliding plate. In the mains is the four two-way valves is utilized in similar roles as the five two-way valve. Pag sinabi namang controlling of double acting cylinder, the longitudinal four slides valves has a control piston for the reversal of the valves. However, the lines of interconnected or separate from one another by means of additional slide. Ganito ang itsura ng for two-way valves actuated. Yan. Dito, yung spring. Yan. Dito makikita spring. Yan. Ito yung number 1, 2, 3, 4. Pag sinabi namang for two-way valve, double pilot valves, longitudinal flat slides. The valve is reversed by means of direct pneumatic actuation. When the compressed air is removed from the comfort port, the control piston remains is respectively piston until it receives a signal from the opposite control port. Ito ay tsura ng ng for two-way valves, double pilot longitudinal flat sides. Ito ang kanyang diagram. Ito magre-remain daw siya ng remain the respectively position until receive signal from the opposite sides control port. Dito magre-remain daw siya ng signal o pag siya ay opposite sides. Okay, maraming salamat po sa pakikinig o sana may natutunan kayo sa aking discuss na for two-way valves unactuated, disactuated, and for two-way valves this set of actuated and indirect and for two-way valve double pilot longitudinal flat sides. Okay, salamat po.